What's up, everybody, and welcome back to another video from the Scalar Learning channel. And today we are talking about the August 2024 SAT, and in particular, my predictions for what to expect on the math portion of the digital SAT. Now, of course, there's going to be much more than what I'm predicting, right? We're going to have questions across all subcategories, but these are the especially hard ones that I think you need to look out for and pay attention to. And just so you guys know, the place where I'm getting this from is just looking back at a lot of previously released practice tests from the College Board, as well as the updated practice test 1 through 3 and questions contained there. I think this will likely give a good indication of what to expect on the August SAT. So without further ado, let's do it. So this is one of the newly updated questions from the existing practice test 1 through 3. So let's go through it. I'm going to show you how to solve this very difficult linear equation word problem. It says, which of the following represents the x-intercept of the graph y equals f of x plus 9 in the xy plane where d is a constant? So first of all, you might just look at this and say, oh, I can do it just from looking at this function, but really they're not talking about f of x, they're talking about f of x plus 9, which is the same as this function as is plus an additional 9. So now to simplify this function, what I'm going to do is I'm going to distribute here and combine like terms out here. So we have 120 dx plus 126d, right? 6 times 21. And then 17 plus 9 is 26. And again, this is equal to that f of x plus 9, which is y. So now we're trying to find the x-intercept. So if you remember, the x-intercept occurs when y is equal to 0. So what we're going to do is we're going to plug in 0. And now since we're trying to find the corresponding value of x that gets us this 0, we're going to isolate x. So first I'm going to subtract 126d and 26. And then now we have this written out. We're going to divide by 120d. And you can see that the x value of the x-intercept is this, negative 26 minus 126d over 120d. And of course, we see that up here in option A. Now, of course, they have these guys flipped around, but it's still the same thing. So why do I think this is going to show up, or something like this is going to show up? The reason why is because otherwise, if this didn't have this strange constant like d, it'd be much easier to plug into DESMOS and work out on the calculator. So I think by throwing in this d, they're making it more difficult, more challenging. And I think generally that's the objective of the College Board. They want to limit your use of just plugging things into DESMOS and being able to solve it on the spot. Now, if you were to solve this using DESMOS, I'm going to show you how you can do it. It's not the easiest task in the world, and I would actually recommend doing this by hand. I think it's faster, but if you were to do it, this is how you would do it. So I'm plugging in f of x as is. Then down here in green, I'm plugging in f of x plus 9 because that's the function of which that we want to find the x-intercept. Then I'm setting an arbitrary value for d. I could set it to 2, I could set it to 3, it doesn't really matter, okay? And then now we're trying to locate the x-intercept. So I can see that my x-intercept is negative 1.15833, whatever, right? Now, as I'm testing the answer choices, I need to see which one matches with this x-intercept value. And I just put in the correct answer because we already know this is right. But when you do plug it in with that same d value that we set to 2, we get the same exact x-intercept. Now, notice as I change this to 3, right, we now get a new x-intercept, but you notice the x-intercept still matches. The next one is the systems of linear equations word problems. And the reason why I think we're going to get something like this, again, is because of these constants. I think that makes it more difficult, and I think the College Board is definitely aiming for things like this. So again, they're stating right off the bat that these two lines are perpendicular. So if they're perpendicular, their slopes must be opposite reciprocals of each other, and that's very important to remember. So I first want to know, what's the slope of this line? So to do that, I'm going to put it into slope-intercept form. We got 7y equals negative 5x plus 1. Then we're going to divide by 7, and we get y equals negative 5 over 7x plus 1 over 7. But the key is that my slope is negative 5/7. Now I'm going to figure out what my slope is here for the second equation in terms of a and b. So again, we're going to isolate y, put it into slope-intercept form. By equals negative ax plus 1. And then we're going to divide by y equals negative a over bx plus 1 over b. So for these two lines to be perpendicular, this has to be the opposite reciprocal of negative 5/7, meaning negative a over b equals 7 over 5. So now what I'm going to do is I'm going to look at these top 3 equations because they all have the same initial linear equation. And I'm going to quickly find the slope of those 3. We're going to check those 3 first, and then if none of them are winners, we're going to go to D. So as we isolate y one more time, we subtract 10x from both sides. Then we're going to divide by 7. Y equals negative 10 over 7x plus 1 over 7. So now we have a slope of negative 10/7. So if any of these options provides a slope of 7/10, then the lines will be perpendicular and we've got our answer. And just coming back to here, looking at negative a over b equaling 7/5, we're trying to get it to equal 7/10. All we got to do is just multiply that denominator by 2, and we now have negative a over 2b is equal to 7/10. So what we're looking for is one of these lines with the slope of negative a over 2b. Now, this one's not going to cut it, right? Because I can tell when I subtract by ax and divide by negative 2b, it's going to be positive a over 2b. So a is out. But what about this one, option B? So if I say 2by is equal to negative ax plus 1, and then I divide by 2b like so, right? Divide by 2b like so, boom, we get exactly what we were looking for. That's 7/10, which is the opposite reciprocal, I should say, of negative 10/7, which means that B is the winner. Done. Now, this is another one of those new questions from the digital SAT practice test, and this one's pretty difficult because notice they're asking for a solution, but you can't just plug it in and figure it out. This one requires some good thinking. Now, the first thing, hopefully, that you notice is if you divide the bottom equation by 5, you get 2x plus 3y is equal to 7, meaning that this line is the same as this line, meaning they have infinite solutions. What that then tells us is that any point on this line is going to be a solution. So the question is, which one of these options where we have r as a constant that we don't know what r is going to always be on this line? So we can solve it one of two ways. We can solve it by hand or we can solve it using DESMOS. So I'm going to show you both options. So to solve it by hand, what you might notice is at least in these bottom three options, they've isolated r in each one, right? Either as x or y. So I'm going to first try plugging r in for y, and then I'm going to see what we get for x. And if I get this, then I know that this is a solution. So let me show you what I'm talking about. So we got 2x plus 3r is equal to 7. Now we're going to isolate x. We're going to subtract 3r from both sides. So now we got negative 3r plus 7 equals 2x. Last but not least, we're going to divide by 2. And we have negative 3r over 2 plus 7 over 2. But check it out. Now that we've isolated x, we get this, and that is exactly this expression, which means that B is our winner. Now I'm going to show you how to look at this in DESMOS. So here we have the linear equation, and here we have the answer choice that we selected. Now, right now, it's on the line, which means it is a solution. But again, we have r is equal to 1. So the question is, as we move r, is this still going to be on the line? And it should be. No matter what r is, this point should always be on the line. And as we see, as we move it, it just goes up and down the line, but always on the line, which means that this is indeed a legitimate solution. The next question I'm going over is this percentages one. I really think they're going to test on this specific language, which is not p% of something, but p% greater than something. So I want to show you how to think about setting up an equation like this, because I always say with percents, you want to set up an equation. It says 210 is, meaning equal to, p% greater than 30. So it's not saying p% just of 30. Well, yes, we are taking p% of 30, but then when it says greater or an increase, p% increased, right? Same language. We would be adding this back on to the original quantity. Now we're going to solve for p. We're going to subtract 30 from both sides, and we get 180 is equal to p over 100 times 30. Divide both sides by 30 to get rid of this. And we got p over 100 is equal to 6. Last but not least, multiply both sides by 100. And p is equal to 600. So 600 is the percent. And that makes sense because 210 is 600% greater than 30. It's not 600% of 30. But if I take 600% of 30, which is 180, and I add it to 30, I get back to 210. So that's the distinction. That's the language that you want to look out for. Again, if they said p% of 30, it would simply be this same equation, but just written like this. The next type of question I think we're going to see is something like this for radical and rational exponents, okay? So in this one, the way you want to be able to solve this is by being very familiar with how to go back and forth between radical format and rational exponent format. So let me show you how to do that. So first we have 4 to the 8c, and that's just a nice exponent as is. Now we're going to convert this to a rational exponent. 4 to the, and then the power is the numerator, the index will be the denominator. So this is really great because now I have a nice equation, and when the bases are the same, I can basically cancel them out and just set the exponents equal to each other. The reason why I think you're going to see something like this is because this is going to be pretty difficult to just put into DESMOS and use a slider to get these to match up. I'm going to show you how you can kind of do that in a second, but this is going to be much easier. So now we know 8c is equal to 7/3. Divide both sides by 8, and c equals 7/3 divided by 8, or which is the same as times 1/8, which means the final answer is 7/24. So right here we have 4 to the 7/3, and right here we have 4 to the 8c, currently with c equaling 1. So you see they're very different. Now to try and get these to match up, which is what we're trying to do, you have to move this slider down like so, and notice, look, right, I'm getting pretty close at 0.3. But it's not exact, right? And then if I drop it a little bit more, now I'm past it. Now, of course, if I put in the answer that I already calculated, you're gonna see that, boom, we get an exact match. But to come up with this simply from a slider is gonna be very difficult. So again, that's why I think we will see a problem like this, because it is really gonna require your understanding of rational exponents as well as radicals. Now, I also think we're going to see something very difficult for an equivalent expression like this. Now, you could use DESMOS for this, right? And the way you would do it is I would replace x and y with like a and b as constants, set them to an arbitrary value, then enter all of these other choices as well, again, with x being a, y being b, and see which one matches the value of the original expression. But it's a lot of work and it would take a lot of time. So instead, the best method here is to do this by hand, in my opinion. So we kind of know that when the College Board is asking you to simplify an expression or show an equivalent expression, they want you to consolidate, meaning they want you to get common denominators. So let's start that process here. And again, I see a nice x minus 8 over here, but in this one, I see something that is kind of complicated and factorable. When I see something that's factorable, I want to instinctively factor it and see where I go with that. So I can factor out an xy, right? So I got xy, and then inside I've got an x minus 8. Now this is pretty interesting because again, I have y times x minus 8 on top. Now what we can see is all I need on this side is just to add an xy to get common denominators. So check this out. I'm just going to throw an xy on the top and bottom, and now I can combine, right? So first on the top, I'm going to distribute, and I get xy squared plus 12xy, and then over here, distribute, I get plus xy minus 8y. Combining like terms, I got xy squared plus 13xy minus 8y over this nice denominator. Now, typically, I'm not going to redistribute after I've factored, because usually they're going to provide it in factored form. However, in this answer, you see right here, they did redistribute it. So I'm going to go ahead and do that. So we got x squared y minus 8xy. And then, of course, you can see that the numerators do indeed match up. So C, therefore, is your winner. That's how you're going to want to take care of business here. Done. Now, this one is a nonlinear function, also involving some tables and a function, plus a transformation. I definitely can see them doing a transformation question like this with a function given, because I think it's, again, going to require some real thinking here. So we're given this function and it says which table of values represents y equals f of x minus 3. Now, if you're not careful and you don't read this thoroughly, you might just be like, all right, oh, they're looking for values of f of x. No, f of x minus 3, where everything is shifted down by 3. Now, the really special thing about this one is it's still asking about x-intercepts in a way. And usually these nonlinear functions or polynomial functions, especially when they're factored out like this, is going to have something to do with x-intercepts, because when it's in this nice factored form, I can see that my x-intercepts are going to be whatever values of x are going to zero out these three different binomials. So we know we've got -6, -5, and 4. And the corresponding values for this one, for all of these values, is going to be 0, 0, 0. Because again, the definition of an x-intercept is when the value of y goes to 0. Okay, now this is very important here, because when we're shifting it down by 3, and that's what happens when we have a -3 outside of the parentheses. Conversely, if it was f of x minus 3 inside the parentheses, this would be a shift of 3 units to the right. This is just a shift down. And the reason why these values are, of course, important is because, look, we see them in every single answer choice, right? Now, we know we're going down by 3. So if they're at 0, we're going to move down to -3. And that's how you can deduce this answer. So again, yes, you want to be well-versed in how to find the x-intercepts, but I think more importantly in this question, you really want to be familiar with this transformation notation. Now we have an example of a linear and quadratic system problem, and I think we are going to see something like this on the digital SAT as well, or some modified version like this. And when we see something about a quadratic and a line and exactly at one point, I want you to think about nature of solutions, meaning the discriminant. That's going to come in handy. Now, you can also solve this using DESMOS, so I'm going to show you both ways. So first of all, if they're intersecting at one point, then we can substitute and solve this system. And since y is equal to c, I can plug c in for y over here. So we have c is equal to negative x squared plus 9x minus 100. Let's set everything equal to 0. Then we have negative x squared plus 9x minus 100 minus c. Okay, now we're going to use the discriminant because it's only supposed to have one intersection point, meaning one solution. So the discriminant is b squared, which is 81, minus 4. A is negative 1 because it's a negative x squared, negative 1, and then c is the full constant. It's not just negative 100, it's just not just negative c. It's negative 100 minus c. And if we have one solution, one intersection point, the discriminant is meant to equal 0. Now we have a great equation that we can use to solve and isolate c. So first I'm going to minus 81 from both sides. I'm also going to simultaneously multiply negative 4 times negative 1 to get positive 4. So I have 4 times negative 100 minus c is equal to negative 81. Now we're going to distribute, boop, boop, and moving up top, we got negative 400 minus 4c is equal to negative 81. Then we're going to add 400 to the right side, and we got negative 4c is equal to positive 319. Last but not least, we're going to divide by negative 4, and we've got c is equal to negative 319 over 4, which means c is the winner. Now I'm going to show you how to do this in DESMOS by plugging in these answer choices. So I plugged in the answer choice that I know is correct, and I plugged in the quadratic. And when we look at the graph, we can see that indeed, yes, we do have one exact intersection point. And then you could try the other three if you wanted to and see that they don't have one intersection point. They either have 0 or 2. So anyways, that's how you do it. Done. Now we have a quadratic and exponential word problem, and the reason why I think we're going to see something like this is because, again, it's got that percentage language, 150% more as opposed to 150% of. So this is a really interesting percentage and exponential word problem hybrid. So let's read this. It says the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. Meaning, if it was X, the next time it's going to be X plus 150% of X, or 1.5 times X. Meaning that when we add these together, remember that X is a 1X. 1X plus 1.5X is 2.5X. So when we're increasing by 150%, or we're taking 150% more, what we're really doing is taking 250%. So that means what I should be looking for in the correct answer choices is a 2.5, not a 1.5. So we can eliminate A and C. Now, the other piece of information that we're given is that it says the model estimates that at the end of 2016, and by the way, t equals 0 in 2015. So in 2016, t equals 1. So we know that with the correct equation in 2016, we should get 180 squirrels. So now let's plug in 1 to both of these options, right? And let's see which one's going to work. Well, I already know right off the bat, D is not going to work because if I plug in 1, I get 2.5 to the first power. And then 2.5 times 180 is 360 plus 90, which is 450. And that is incorrect. But if I plug it in here, I get 2.5. And then 2.5 times 72 is going to give me 180 because double 72 is 144 plus another half, which is 36, gets us to that right answer. So that means B is the winner. Done. Now this one is a area and volume problem, and I definitely think we're going to see something like this. And I'm going to give you a couple of things that you need to remember in order to be successful on questions like this. So they're giving you an equivalency in length, but then they're asking about area. So where a lot of people make a mistake is they're like, oh, well, it's 4.36 square miles, right? And so to convert from miles to yards, I'm just like, all right, well, I multiply by 1760 yards because that's equivalent to 1 mile. We do our typical conversion, cancel out, multiply, and I think this multiplication would end up with B. But B is actually not correct. That's because we can't use the equivalency in length when we're talking about area. So when we talk about length versus area versus volume, and if we have a relationship between miles and yards for length, like we do here, which is 1 to 1760, To get the equivalent ratios in area and volume, use exponents as follows. And think about it. Area is units squared. Volumes is units cubed. And we can apply that same logic here, right? If 1 mile equals 1,760 yards, for area, for square miles, 1 mile squared is going to equal 1,760 yards squared. Likewise, for volume, 1 mile cubed is going to be the same as 1,760 yards cubed. So now this is the ratio. This is the equivalency that we want to use. And obviously 1 squared is 1, so we can just rewrite that as 1. But what this means is when we have 4.36 miles squared, and we're trying to convert to yards squared from miles squared, we now see that the correct equivalency is 1760 squared to 1 squared, which is just 1. Now these units cancel out, and we can carry out the calculation. And here we get our answer, this huge number, approximately 13 million, which means D is the winner. Done. Next, we have a circle equation problem. And the reason why I think we're going to see something like this is because for a lot of these circle problems, you could just write it into DESMOS and quickly calculate the diameter, the center, all that good stuff just from looking at the graph. But when we have these bizarre constants, like P, right? And now we're trying to solve for this random N thing. It definitely makes it a lot harder, especially if you're relying on DESMOS. So let's take a look at this question and see how we can break it apart. It says the length of the radius of the circle is NP, where N and P are positive constants. What is the value of N? The first thing I noticed with this problem is we should be able to divide everything by 8 just as a starting point to simplify this. So let's start there. 8 divided by 8 is just x squared. 112 divided by 8 is 14. Then we have y squared. And then 64 divided by 8 is -8. And 448 divided by 8 is 56. Now at this point, I actually can solve this in DESMOS, but I'm going to show you how to solve it by hand first. I think it might be a little bit faster completing the square, but then I'll show you how we can do this just as well in DESMOS. So to complete the square and get this into standard form, what I'm going to do is I'm going to look at my b term for both the x and the y. And again, completing the square, we take half of this, which is 7p, and square it and add that to both sides. So again, 7p squared is 49p squared. Half of -8p is -4p squared is 16p squared. And if I'm adding it on the left side, I also got to add these on the right side. Now, as I add these together, -56 plus 49 is -7. -7 plus 16 is +9p squared. So remember, whatever's on the other side of the equal sign for a circle equation is going to be the radius squared. Now, of course, I could factor this and get the coordinates of the center in terms of p, but they're not asking about that. So the square root of this is going to be the radius, which is 3p. And now we go back to np. They're saying, what is n? Well, n is this constant right here, which is 3, and that's how you do it by hand. But now I want to show you how to do this in DESMOS. So now I put in the simplified version. Actually, it doesn't even matter. You could have left everything as is, but just to make it a little easier to type in. So now here we have our circle, right? And again, looking at the top coordinate and the bottom coordinate, which DESMOS gives you, we can see that the diameter, meaning the distance from the top to the bottom going through the center, is 14 minus 2, which is 12. So if my diameter is 12, that means my radius is 6. And now notice, since I set p equal to 2, what times 2 is going to give me 6? That's going to be that n value. And again, we come back to that same answer of 3. So DESMOS can be used. You just got to be a little bit savvy with it. But anyways, these are the 2 ways to carry it out. 3 is the winner. Done. Next, we have a really good one from right triangle trigonometry, and this is all about mean proportionals in right triangles. I really think one of these problems is going to show up. I've been seeing them more and more on the College Board practice test. So the main thing to remember is if we have a right triangle, and from that right triangle, from the right angle, we drop an altitude, okay? The main thing to remember is this. We now, of course, have 3 right triangles, the green one, the red one, and the purple one. But what's more important about those 3 right triangles is that they are similar, meaning that they are proportionate. And we can also see that, you know, for the green one, this would be the little leg. For the red one, this would be the little leg. And for the big dog, this would be the little leg. I point that out because we can make equivalent ratios of little leg over big leg over hypotenuse, big leg over hypotenuse, so on and so forth. So now let's fill in these values. Obviously, they gave us messed up values because they're trying to make this as hard as possible, but still very doable. So I know that AD is 121 over 3. AB is 11 rad 130 over 3. And DC right here, that's our unknown. Now, using the fact that all three of these triangles are similar, we can set up some really cool proportions. So let's start with these two values because both of these values belong to the red triangle. So this right here is the medium leg of the red triangle. This is the hypotenuse of the red triangle. So we can set up a medium leg over hypotenuse as 121 over 3 over 11 rad 130 over 3. Now, could I have flipped it around? Absolutely. I could have put hypotenuse on top of medium leg. It doesn't matter. But notice that I'm labeling the proportion because I want to be consistent on the other side as well. Okay, now let's see if I can get a nice medium leg over hypotenuse of another triangle that involves this x. Well, I can for the big dog. This is the medium leg of the big dog, and this is the hypotenuse of the big dog, 121 thirds plus x. So now we have is equal to medium leg, which is 11 rad 130 over 3 over 121 over 3 plus x. Now we have this beautiful proportion. Now we are going to cross multiply. So these guys multiplying each other, we have 11 rad 130 over 3 times itself. So that gives us 121 times 130, right? Because rad 130 times itself is just 130 over 9. 3 times 3 is equal to 121 over 3 times 121 over 3 plus x. Now, I can go ahead and solve for x algebraically, or I can just plug this into DESMOS, which is going to be much easier. So let's do that. So there we have the equation. I put it in exactly, triple check that it was correct. And now we have this line, and this line, the x value of this line is going to give us our solution. It always intersects the x-axis and gives us that nice point that we can click on, and we see the answer is 3. So 3 is the winner, done. And just make sure you remember, again, any right triangle, if we have a right triangle and we drop an altitude from the right angle, we create 2 more right triangles, and all 3 right triangles are going to be similar. Here's my last one for the predictions, a nonlinear function question. This is a very gnarly polynomial function question again, and it's got these crazy constants that we have to consider. So let's go ahead and give it a shot. In the given equation, p is a positive constant. The sum of the solutions to the equation is 20/3. What is the value of p? So what I'm going to do is I'm going to go through and I'm going to find all the solutions for each one of these little binomials and trinomials. And the way I'm going to know the solutions are, since this is equal to 0, what value of x is going to zero out each of these? So I'm going to take each one of these expressions and set them to 0 and then solve for x. So for the top one, if I minus p and divide by 3, I get x equals negative p over 3. For the second one, I'm going to add 45 to the other side. So 5x squared equals positive 45. Divide by 5, x squared equals 45 divided by 5, which is 9, and x equals the square root of 9, right? Square root both sides, and we get plus or minus 3. Now for this last one, I'm going to start by dividing everything by 2, just to simplify it. So I get x squared minus 8x plus 3p is equal to 0. Now the question is, how the heck do we factor this? Because we have this weird constant. How do we find the solution? Now, again, we can go back to DESMOS, maybe set p equal to something and try and figure it out that way, but that's going to be a nightmare. But there's a little shortcut that we can leverage here, okay? So we're trying to get the sum of all these solutions. We're going to add them all up. So I don't even need to know the individual solutions here, but if I just know the sum of the solutions, that's fine, because I can add that sum to these other ones and set it equal to 20 over 3. Well, remember that really, really valuable equation to get the sum of solutions of a quadratic, which is simply negative b over a, where this is a coefficient, which is an invisible 1, b is the negative 8, c is 3p. So guess what? I can get the sum of solutions. It's negative 8, which is positive 8, over 1, which is 8. So even though I don't have the official solutions for this last one, I know that the two added together are 8. And that's fine because we're going to add them all together anyways. So we got 8 plus 3 plus negative 3 plus negative p over 3 is equal to 20/3, right? That's what it said. It said the sum of all of them is equal to 20/3. Now, these cancel out, and then now I've got this really great equation. 8 plus negative p over 3 is equal to 20/3. So just making a little bit of room, I'm going to subtract both sides by 8. So we got 20/3, and then we're minusing 8. But again, I want to combine it with this fraction. So I'm going to put it over 3, right? So multiplying 8 by 3, we get 24 over 3. Again, 24/3 is the same as 8, right? And this is equal to negative p over 3. Now I got 20 minus 24, which is negative 4/3, is equal to negative p thirds. And since we got 3 on the bottom, right, cancel those out. Negative 4 equals negative p, which means p equals 4. So 4 is the winner, done. Now what I'm going to do is I'm going to use DESMOS to verify. Now I've got the function out here, and now we can see all the zeros are where we have all these x-intercepts. So I'm going to click all of these values, and now I'm going to add them up. And when we add them all up, we get 6.666, whatever, and we want to make sure that that's equivalent to 20 thirds, and 20 thirds is the same, which means that this is indeed correct. That's how you do it. Done. That is it for my August 2024 math predictions video. I hope you find this video helpful. If you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. That's it, everybody. I wish you all the best of luck on this SAT, and I will see you in the next video. Take it easy.